Types of solids. We talked a lot about gases. We talked about liquids. Solids come in two basic forms: crystalline or amorphous. Crystalline means that they've got a well-ordered arrangement of their particles. Amorphous means there's no pattern, there's no order. They're just kind of randomly jumbled together. And then the crystalline solids can be divided into three categories: molecular, ionic, and atomic. And that's based on what the particles are, what kind of particles make up the solid. So here's a flow chart. So we've got molecular solids, ionic solids, atomic solids. In a molecular solid, the individual pieces are molecules, hence the name molecular solid. In ionic compounds, the individual pieces are formula units formed of cations and anions, so it's ions. And in an atomic solid, guess what the pieces are? Atoms, okay? So atomic solids vary in their melting point. Some are really high, some are really low. Ionic solids have high melting points because the forces that hold those ions together are very strong. And we talked about the relationship between forces holding the units together and the melting and boiling points. Molecular solids tend to have low melting points because the forces that hold the molecules together are weak. And then this is a lot of detail. So the forces that hold molecular solids are the intermolecular solids, the dispersion forces, dipole-dipole forces, and hydrogen bonds. So it depends on which of those forces is present in terms of whether it has a high or low melting point. But mostly these things have low melting points. Ionic solids held together by ionic bonds, the attraction between positive and negatively charged ions. So these have a very high melting point because that bond strength is very high. And then atomic solids, and the atomic solids get divided into three more categories based on how the particles are held together. There's covalent, non-bonding, and metallic. In a covalent atomic solid, this is something like silicon or a diamond. This is where the individual atoms are covalently bonded to each other. So in reality, the piece of substance is really one ginormous molecule. These types of solids are pretty unusual. There aren't that many of them. But because they're held together by covalent bonds, they're going to have high melting points. Then we have non-bonding atomic solids. This is a common kind of atomic solid. These are held together by dispersion forces. Because the individual pieces are atoms. Atoms can't be polar. They can't have dipole-dipole forces or hydrogen bonds. So the only thing that can hold them together is dispersion forces. So these things have very low melting points. And then the metallic solids are held together by metallic bonds, and we'll talk about that. So here are slides that give more details. Pretty much said that. Here's an illustration of a diamond. So individual carbon atoms, and they are covalently bonded in this very uniform structure. A diamond is a crystalline solid that is also a covalent atomic solid. So all these categories can be confusing, and yet we're familiar with categories like this in everyday life, right? A car can fall into multiple categories. There's gas versus diesel. There's size of car, compact, subcompact, luxury, etc. Then there's different brands of cars. Is it a Ford or a Chevy? And then even then within the Ford, is it a Mustang or what is it? And so we can have one object that fits into multiple categories. The non-bonding solids, low melting points, like xenon melts at minus 112. So it's a gas at room temperature. Metallic solids are held together by metallic bonds. And metallic bonds are kind of hard to describe. The simplest way to think of it is that we have positively charged ions, and we know that metals tend to form positive ions. But now instead of giving their electrons to a nonmetal and forming ions that are attracted to each other, these electrons are just kind of floating around the cations, and it makes like a sea of electrons. I think we have a picture. Yeah. So here we have positively charged metal ions. Each of those became positively charged because it lost an electron. The electron isn't really lost, it's just free to run around. I think of this as the nuclei is mom at home, and the electrons are the little boys. And so here what's happened is the moms all sent their kids out to play in the neighborhood, and everybody's kind of watching over them, and so there's this community that's all kind of tied together by these electrons. You do not have to have a good understanding of the electron C model to pass this class, but I'm compelled to tell you about it anyway. So this is something you should be able to do. If I give you a formula, you should be able to identify whether it's a molecular, ionic, or atomic solid. And this is easier than it may seem at first, because we studied nomenclature and we learned to classify things in terms of molecular compounds and ionic compounds. What is the thing that helps us to recognize an ionic compound? It has a metal in it and a nonmetal. So if we look at these three different substances here, which one is ionic? B, because we have calcium, which is a metal, and oxygen, which is a nonmetal. This contains ions, and that makes this an ionic solid. So B is ionic. NH3, does that have any metals in it? No. So it can't be ionic. Is it an element? No, because it has two different elements in it. It's a compound, right? So it's not an atomic solid. It has to be a molecular solid. It's a molecular compound, and we learn to name it using those rules. What about krypton? This is atomic. So atomic solids are just going to have one element in them. Just one element. Ionic solids will have a metal and a nonmetal. Molecular solids will have more than one nonmetal. Okay?